begin with the first one, which says, write the chemical equilibrium for the reaction. H2, this is in gaseous state. I2, which is also in gaseous state. So we have a forward and backward reaction here. We have 2HI also in gaseous state. So we can see that this reaction all have the same state. They are not in different states. So this is not a heterogeneous reaction. It is, some textbook call it homogeneous reaction because all their states are the same. So let's write out the chemical, that is the chemical equilibrium for this reaction. So let's begin with number one. We are going to follow the same format for this as the equation, okay? So for the chemical equilibrium for this, KEQ is equal to, so the product here is HI, okay? So we'll put this in the brackets. So the power is going to be the coefficient here, which is raised to the power of 2, all over now let's go to the reactant. So the reactant is H2 in a bracket. The coefficient of the hydrogen here is just 1, so we can just, it's the same. Then the I2, so this is I2, okay? So the coefficient of I here also is 1. So this is the chemical equilibrium for the reaction given in question 1. As simple and as straightforward as that. So let's move on to the second question, which says, write the chemical equilibrium of the reaction. We have CaCO3 in solid state. We have CaO in solid state. So that means the reactant is CaCO3. The reactant is in solid state. While for the product, we have CaOS, that is in solid state, CO2 in gaseous state. So as you can see, this is a heterogeneous reaction because they have, or they exist in different states. So let's write out the chemical equilibrium for this heterogeneous reaction. So let's begin with 2I. The chemical equilibrium will be equal to what we have here. This is in solid state. So coming to the right hand side, here we have solid state. So we are going to consider only the compound that is in the gaseous state. So the chemical equilibrium becomes CO2. So this is the answer for the first one because the CaCO3 is in solid state. The CaO is also in solid state. So we write out the chemical equilibrium considering only the compound that exists in the gaseous state. Okay. So let's move on to the next one, which is 2II. So the equation, the chemical reaction is CO2 in gaseous state plus 2H2 also in gaseous state. And we have a forward and backward reaction here, and we have the product to be CH3OH in liquid state. This is also a heterogeneous reaction because they exist in different states, which is in gas and also liquid. So let's write the chemical equilibrium. So it's going to be KEQ is equal to, remember the relation for writing the chemical equilibrium is the product over the reactant. So looking at this now, the product exists in liquid state, so we are not going to take the product into consideration. So this is just like saying 1 all over going to the reactant, we have CO2 in gaseous state and 2H2 also in gaseous state. So now for the reactant, since they're all in gaseous state, this becomes CO2 and we have H2. This H2 is going to be raised to power 2 because the coefficient here is 2. So this is as simple as that. This is the chemical equilibrium for the equation, for the reaction in question 2II. Okay, so it's just as simple and as straightforward as that. Okay, we just need to check out the state. The state is very important when treating mathematical problems under chemical equilibrium. Okay, so let's look at the last question we have here, which says, consider with the reaction H2 in gaseous state, I2 in gaseous state. We have a forward and backward reaction, and the product gives us 2HI also, which exists in gaseous state. So we are considering this reaction given the following concentrations. So the first reactant H2 has a concentration 0.1 moles, while I2, the second reactant, has a concentration of 0.2 moles, while the product is 0.2 moles. So now the question is asking us to calculate the chemical equilibrium of the reaction. So for us to calculate, to solve this, the first step we need to do is to write out or to bring out the chemical equilibrium for the reaction first before considering the concentrations that has been given in the question. Okay, so now let's write out the chemical equilibrium. So the chemical equilibrium for this now becomes, this reaction becomes, so let's look at the product, net product over the reactant. So the product here, since it exists in gaseous state, so this becomes Hi raised to the power of 2 because the coefficient here is 2 divided by, now let's go to the reactant side. We have H2. So here is H2 multiplied by I2. Okay, so since we've written out the chemical equilibrium for the reaction, now we can move on by substituting the values of the concentration that has been given. Please kindly note that if you're given a question of this nature and your first step, which is the chemical equilibrium for the reaction, if it's incorrect, then the final answer you get, the mathematical final answer you get, will also be incorrect. So you have to ensure that the chemical equilibrium you're writing for each reaction is written out correctly. Okay, so now let's substitute in the concentrations. So we have the concentration of the product, which is 0.2 all over that of the first reactant, which is 0.1, multiplied by the second reactant, um, which is 0.2. So here we have 0.2 all over 0.02. So dividing 0.2 by 0.02 gives us a value of 10. So what this means is that the chemical equilibrium, given the concentrations of the reactants and products, gives us a value of 10. Okay, so this is just as simple and as straightforward as this. So viewers, if you have any question under this topic, kindly bring in your questions and we will take it up from there. Okay. Um, Remember, the video is sponsored by Proch Connect. Thank you for your continuous support on this application. Do not forget to invite your friends and well wishers to use the applications for them to get exciting and educative videos that will be of high beneficial to them. Okay, I am your pro guide Aisha Bende. Thank you for watching once more. Bye for now and God bless you all.